Right, this is section 2. Going to look at scatter plots, dot plots, and stem. So a scatter plot is a graph where two variables are plotted along the two axes, and typically these are used to look for any pattern. So for example, I have the height of a certain country's president and their main opponents in the election campaign. So you see the height of the president versus their opponent. I want to figure out which one of these are the correct scatter plot. Well, one thing that I notice is if I just look straight here, these aren't going completely down or completely up. Okay, in other words, they're kind of all over the place, but each one of these specifies a data point. In other words, this is the point 187, 172, the XY point, and so it would make sense the correct graph. And of course you could go through and check each one of these. It says, does there appear to be a correlation between the president's height and the opponent's height? When we have a correlation, you would see some kind of trend in the data and all over the place. There's no general pattern with it. All right, let's look at dot plots. This is a graph used to compare frequency counts. So these dots are frequencies. This table represents the volume of a generic soda brand. Each dot plot represents the data. Now, of course, this would be more helpful if these were in ascending order, but what I do is I look to see, for example, here is a 50, and this one doesn't have a 50, so I know that's not the correct one. So then what I do is I look, like this one has 80 pretty high, and I only see 1, 2 80s, which is this graph, so it's the correct graph. All right, where all this is a count, the frequency of the number of points. So in other words, the 80, you see 2 there, 85, you see 1 there, 50, and so on. It says, does the configuration of the points appear to suggest that the volumes are from a population with a normal distribution? Well, if you just took the data points and kind of drew a line that represents their heights, it does distribution. It does look, draw it again, it does look pretty much bell-shaped. Are there any outliers? I definitely outlier this 50 is pretty far away from the rest of the data. So I would consider that. Let's look at a stem plot. Should be stem, not steam. These are also called stem and leaf plots as well. They're just like a histogram. If you turn this to the left on its side, they would look like a histogram. Where what you're doing is you're taking, say, let's look at this one since I didn't write all over it. This would be the values of 93, 94, and 95. In other words, these are the tens, the 90, 80, 70, 60, 50, 40, and these are the one values. Can be created in different ways. So this data represents the height of a rubber user. Which stem plot matches the data? Well, again, I'm looking at, this is going to be 94. This would be 100, 100, 100, 101, 103, 103. So I would look over here. I probably would first try to find the 150s. I see a 150, and that's the only thing I see. So I know it can't be this one because there's no 159. So I got that one marked off. Then I look to see another difference, and I see that the 140s have a 140 and a 149. There's a 149, which is not present here, so it cannot be that one. And again, you could sit and put these in order and write each individual one. 94, there's 94. I have, looking for 100, there's 100. Then next I have, can't seem to find it, there it is, 104. That's your 104, and so on. So that's how these are being constructed. Right, it says, is there strong evidence that suggests the data are not from a population having a normal distribution? I would say no, because again, if you looked at this and flipped it over on its side and made these bar graphs, that looks pretty normal. Looks like your bell-shaped curve.